This is the next question. A 200-volt generator with 200 ohms of internal resistance is feeding a lossless transmission line. The characteristic impedance and the length of the transmission line are 200 ohms and 10 meters respectively. If the line gets terminated in a resistive load of 100 ohms, operated at 37.5 megahertz of frequency, find the following. Part A of the question, the amount of current drawn from the generator. Part B of the question, the magnitude and phase of current that is flowing through the load. Right, and part C of the question, the power delivered. So power delivered refers to the load part. Okay, fine. All right. So basically, our idea is that, okay, let's try to look at a diagram. Let's try to write a simple circuit, okay, representing what has been given. Right. Now you see, okay, I'll go back to the question once again. I'll read that. So you see, whenever a value like this is given, okay, uh, without mentioning any other parameters, if a voltage or current is given with respect to a supply, we know that it is a root mean square value, correct? I'm taking this concept directly from the electrical subject. right? Basic electricals, right? Wherever a voltage is given as it is, right, it means it is the RMS value. Okay, so that's the first thing which we need to remember. Okay, so let me try to write a simple circuit uh, for this reason. So let's start with the power supply. So they say that there is a power supply. Okay, so this is a power supply, right? It's a voltage source and the value is given. So you see that it's a AC, right? Power supply. So I can say this is say 200 volts, and there is an internal resistance. Okay, so there is an internal resistance. It mentions that you have a resistance associated with that, right? So normally, again, this is from the basics of electrical, right? If a internal resistance comes, it is in series always. Okay, so if you see, that's also 200 ohms mentioned, right? Then there is actually a 10-meter transmission line. This is connected to a transmission line, so its length is given. So I assume that this is 10 meter. Okay, let's say this is 10-meter line. How do you characterize that? There is a impedance, right? Characteristic impedance of 200 ohms. Okay, right. Then we connect that to a load. Correct. So this is what has been mentioned. So there is a load, and what's the value of the load? So I think that's given. It's connected to a resistive load of 100 ohms. Are you okay with this? Okay, now you see, okay, we are talking about the source now. When the source looks into the circuit containing the load plus what do you call plus our this one, what is that? Plus the load and the transmission line. Okay, so this should look like a ZI for us, correct? Right? It just looks like a, for a source, it is simply a, I can call it as, it can be replaced by its equivalent. Okay, this is equivalent to, let me try to draw another version of this. So this is the same supply. This is the internal impedance. Okay, this is the this is the internal impedance of the source. All right, now I replaced everything right side of that. That means my transmission line plus the load. Okay, this whole thing I'm going to replace it as a single resistor, single impedance. But that value, I don't know, I cannot write directly as now, because I have to calculate, right? So that is this value, whatever. So what, when this looks inside the circuit, it can see a ZI. Okay, so now also it's the same thing. I have a 200 volt power supply. There is a 200 ohms of internal impedance, but whatever you see here, this itself is the Z in, or I think the notation we gave was ZI, right? Okay, fine. So I'll stick to that. So that's the ZI which it can see now. So the meaning is that if you want to do any calculation, you try to first you try to calculate the ZI value. Okay, so what is the equation? Let's start with the equation for ZI. Just try to recall what is the equation for ZI. So the ZI is equal to, it's a Z naught multiplied by I think, just try to recall this, ZL plus J times Z naught tan of beta L, right? I will show you the equation, right? So let me write this first, then I'll show you. Okay, Z naught plus J times ZL times tan of beta L, right? We are writing this because it's already mentioned that this is a lossless line. Okay, so directly I'm writing this equation. Otherwise, the ZI equation is slightly different. You have the gamma coming into picture. But since the question mentions that the line you are considering is a lossless. Okay, you see, it's a lossless transmission. So because of that, you can directly upgrade your equation to this directly. Okay, right, fine. So I think all the values are given. Beta, let me see, beta L. Beta is 2 pi by lambda. Okay, lambda can be calculated, correct? So let's calculate that first before we calculate a beta. Okay, so what is the equation for beta? 2 pi by lambda. Okay, so we have multiple options here. Okay, I'll teach you both way, right? Whatever you feel easy, you can follow that. Okay, so again, there are multiple methods available here, right? You don't have to calculate everything and keep it ready. Okay, first thing is that simply think that the beta is equal to, equation for beta is 2 pi by lambda. Okay, you don't calculate a lambda. F is given, you can calculate lambda for sure, but don't do that. You hold on. I'll show you how this gets cancelled. Right. Now you try to convert the length, right? Convert the length in terms of lambda, right? So L is equal to 10 meters given. So, right. Okay. In that case, I need lambda. Sorry, my mistake. So we need to do that, right? So let me calculate lambda here. So lambda is C by F. C is equal to 3 into 10 to the 8 divided by 37.5 megahertz. So 10 to the power 6. Yeah, frequency is 37.5 megahertz. I think, yeah, you see here, operated at 37. Right. So that's the value of the frequency given, right? We'll substitute here and we'll calculate. Okay, just find out how much you get as the lambda value. So we get a value of lambda equals to 8. So 8 is fine for us. So I need to multiply and divide by 8 now. So because L is 10 meters, so I can write, I have to write in terms of 10, right? So 10 into 8 and divide by 8. Out of which the numerator 8, I am going to write it as a lambda now. So this is 10 by 8 lambda, correct? So which is 5 by 4. This is 5 divided by 4 times lambda. So you see I have a value called beta L to be substituted. So beta is 2 pi by lambda into yes, 5 lambda by 4. Now you see I don't have to calculate this. Lambda anyway gets cancelled, correct? So this is 10, yeah, 10 pi by 4, otherwise 5 pi by 2. This is the easiest way, okay, according to me. Anyway, definitely you can, otherwise you can substitute beta, get a value of beta, multiply that by 10 because L is 10. Yes, right, you can do it. Yes, that's another way. Right, so let us substitute all the values here. So Z0 is given, which is 200 into ZL is given, that is 100 plus J times Z0 is once again 200 tan of 5 pi by 2 whole divided by, this is plus J 100 tan of 5 pi by 2. So the angle should be in radians mode for this calculation. Okay, so again remember, if you do the other option for the calculation of beta L, correct? So then also this should be whatever you write inside, right? You will not be writing like 5 pi by 2. You write some number over there because beta L, when you calculate, right, I should not miss that the whatever tan ratio I take, still it should be in the radian format. Okay, so just remember that one point, because those who do in the other method, right, they miss that we have to bring it into the radians mode. Math error, I don't think so. Maybe just check. Only calculate a numerator and see what you get. Numerator is also giving you a math error. Just a minute, I'll try to calculate from my side. So 200 to 10. Ten 90. So in that case, we need to take the tan 5 pi by 2 outside, right? Before you do the calculation, take it out, right? So let's do that. Okay, in that case, all right, so that is 200 into, let me take the tan of 5 pi by 2 outside in this, right? Then I have 100 over, correct, tan of 5 pi by 2 plus, this is j 200. Okay, whole divided by, once again, I'll take tan 5 pi by 2 outside. So this is 200 divided by tan of 5 pi by 2. This is plus j100. Okay. Okay. So the zi value is 200 into 2. So that is equal to 400 ohms. So now I'll move back to the equivalent circuit which we had drawn. So this is now equal to 400 ohms. Okay, now you see whatever voltage that is being generated by the generator is not our Vs, because according to us, whatever the voltage that we apply at the input of our transmission line, that is the Vs, correct? So where do you measure the Vs in this circuit, on the equivalent circuit? It is over here. So right after the 200 ohm resistor, correct? Yes, so that's what we calculate, that is the Vs. Okay, so I'll just make a note here. So this will be the Vs. Now how do you calculate the Vs? Again, it's not related to the transmission line concepts. You have to apply something else, right? So basic concepts, some circuit analysis concept, right? We have a concept that is called as a voltage divider rule, correct? So let me write that equation now. So Vs is equal to the, you see, I'll say in words and I'll write simultaneously. Okay, so it says voltage across any resistor is equal to, right, the main voltage, which is a supply voltage, correct? That's equal to 200 into the resistance across which you are trying to measure the voltage, right? That is 400. Right now I measure, whole divided by the sum of every resistance that is present, right? So there is a 200 ohm resistor, internal resistance, plus this one which is 400. Okay, so that will be the value of Vs. Yeah, please calculate. Okay, so that is 133.3 volts. Again, this comes in the RMS format only. Now, now you see, I'm answering the first part of the question, right? The first part of the question says find out the current drawn from the generator. It's very easy to calculate. I just have to write. So I can write what is current drawn is IS, correct? Source current, right? Current that is entering into the transmission line, that is equal to, right, the main voltage, voltage that is supplied, how much? 200, divided by the sum of both the resistances, isn't it? One is 200 and other one is 400. Yeah, so that is 2 by 6, 1 by 3, 1 by 3 amperes, 0.333 possible. Okay. Okay, then the second question says that find out the flowing in the load, right? In the sense, what is the current flowing into the load? Find out. All right. All right. Now you see, it is given that okay. So you see, it's a lossless line, correct? So lossless line will have only the in the sense phase will remain same, no change in the phase, right? So it's something like if you apply the 200 angle 0 degrees to your line, the same, the value might change, okay, but the 0 degree itself will remain same. Okay, so because of that, right, again, angle is not given here. We will not calculate the angle, right? They ask a question, but if it is not possible to find, we don't find. Okay, absolutely fine, because questions can come in any way. We have to think, right? Okay. Now, so this is part B of the question. I'm trying to answer that. So what I want to find out the current that is entering. So we'll try to calculate the power first. Okay, so before because if you have a power, then I can calculate a current because I know the voltage, right? So I know the voltage, I can calculate. So that's the reason, right? So let's first calculate. I'm answering B and C together. So first I'll calculate the power, right? So power is equal to, so I'll calculate power delivered. This is actually the average power, right? It's voltage. You have options. You can do I square into R, right? Otherwise you can write the V square divided by R. That's also fine. Okay. Otherwise V into I. Okay. Now you see, I think IL is 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 known, right? Okay, not IL. Okay. Now you see, it's a lossless. So whatever is your input power will be going to the output power, right? So average power, what we do, we calculate Vs into Is. That itself is the delivered power because lossless line. So only in case of lossless, I can apply this. So calculate this. I think Vs is calculated 133 by yeah. Please tell me how much you got for 44.38 watts. All right, fantastic. Okay, now I got a power. This is the power that is delivered, right? Right. Power delivered, it's equal to power supplied. Okay, right. Now we understood that, we saw that. Now you calculate the current. Now you see the same power, P average is equal to, at the load side, you can either write IL load current square times RL. Are you okay? Because this is the one equation which I can use to calculate a IL, right? So that means if I want to calculate IL, this is square root of the P average divided by RL. All the values we have, let us substitute. So this is 44.38 is this. No, RL, look at the RL value. RL is 100. Right? Load. So related to load, I'm calculating. So now we calculate. Sure. Point 0.66, 0.66 current, right? Amperes. That's all. Okay. Do you have any doubt? Okay, let's proceed. This is the next question. A transmission line of characteristic impedance 50 ohm operating at 300 megahertz okay uh, is terminated by 50 plus J50 ohms. Yeah. Calculate voltage standing wave ratio reflection coefficient. Is a question. So, do we have a straightforward equation? Can you calculate the reflection coefficient? Can be directly calculated like this, right? Equation for rho is there, right? ZL minus Z naught by yeah, right. So directly let's calculate that. See here, this equation. Yes, if it is RL, it's RL. Otherwise, it is ZL. Okay, right. So rho is equal to now it is ZL. Okay, because it's complex. Right. So ZL numerator is ZL plus Z naught, isn't it? Or ZL minus Z naught. ZL minus numerator. Yes, 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 correct. So ZL is 50 plus J50, correct? 50 plus J50 minus 50 divided by 50 plus J50 plus 50. Okay, 0.2 plus 0.4. Okay, now what should we do? We should convert this into the S, right? What is the equation for S? Perfect. So because it says, I think the equation should be 1 plus magnitude of rho divided by 1 minus magnitude of rho, correct? So simply convert the above rho into the required format, that is R angle theta format. Okay, 0.44447. Okay, all right. Okay, I can write simply that is a magnitude. I don't want angle. Okay, so simply substitute. So that is 1 plus 0.447 divided 2.616 is the required S value. Perfect. Let's move. Okay, the next question is a 50 ohm lossless line connects a signal of 300 kilohertz to a load of 100 ohms. If power delivered is 50 milliwatts, calculate part A of the question, VSWR. Part B of the question, positions of first Vmax and the first Vmin on the line. Then values of Vmax and Vmin. Impedance at points of Vmax and Vmin. Okay, so this is what we need to calculate. This has four subparts in this question. So let's try to write what has been given first. A 50 ohm lossless line. Whenever related to a lossless line, a resistance is given that corresponds to the Z0 value. Okay, so Z0 is equal to 50 ohms. Right. Then connects to a signal means there is a frequency is given. F is equal to this is 300 kilohertz. Okay, then what is given? Load is given, so I can write as ZL value 100. And okay, power delivered is given, so I can write P is equal to, it's delivered to the load, only one is given, so doesn't matter what you write. So the power is 50 milli. Uh, V no VSWR is the S, right? Okay, okay. Okay. First calculate a row. Yes, yes, yes. Calculate a row first. Correct? That's right. So RL minus R naught. RL plus R naught. So numerator is 50. Denominator is 150. Correct? So yes, that's right. 1 by 3. This implies I can go for S now. The magnitude is 1 by 3 only, right? So numerator is 1 plus 1 by 3. Denominator is 1 minus. Yes, yes. Correct. Perfect. So 2 by 3 by 1 by 3, so it's 2, I guess. 2, right? Huh, yeah. Perfect, perfect. Yes, yes. What you told is right. Okay. Right. So I can see that the ZL is actually greater than the Z naught value here. Okay. That means Vmax is located at the, it's closer to the load. Okay. Right. So V min is normally located at the lambda by 4 position only. Okay. So I'll write one point just for your reference. Anyway, you know the answer directly. You can write it, right? But this is, since we are solving for the first time this kind of problem, I'll make a point. Okay. So that is, since the ZL is greater than Z naught, again, you can take a magnitude. That's fine for us, right? This implies the V max is, right? So you see ZL is greater than Z naught, V max is located at the load itself. Okay. And the V min, what is the V min? It is located at lambda by 4 from load. So position of V min equal to position of V min equal to, how do I calculate? It's a lambda by 4, right? So do we have lambda now with us? No, I don't have it. So let's calculate. So lambda is equal to C by F. So 3 into 10 to the 8 divided by F is given, right? How much? 300 kilo into 10 to the 3. Okay, that is 1000 meters. Lambda is 1000. So this is 1000 by 250 meters. Right. Okay. So I need the values of Vmax and Vmin. Okay. So let's try to calculate. First, we'll go to the maximum value. Yes, definitely. Please calculate that. I'll teach you another method also. First, please calculate that. So what's the equation for Vmax? Hmm. Hmm. R naught into 1 minus magnitude of 4. I have it. One second, I have it out. I rewrote that equation. It's related to any line, or let me just check that once. Okay. That is Vs into, not Z naught into, correct? Right. So that's why I got confused. How we converted resistance into voltage. Okay. Yeah. Okay. No issues. Just try to calculate. That is Vs, right? Okay. But the voltage is not given, right? So I am not able to calculate using this equation, right? Yeah. Okay. Let's go with the other method. So I know the power, right? That actually, when the voltage is not given, you should have any other format in which either voltage can be derived, or something like you have to modify that to get something. Okay. So you see, P is given. So P is equal to, this is 50 milliwatts. At the load side, this itself is the power. Okay. but I know that maximum voltage occurs at the load, right? So I can call it as, this is either you can write VL, voltage at the load, or you can even write V max, correct? V square by R, because load is given, right? V square by ZL. Voltage at the load divide whole square divided by the value of the impedance, value of the resistance, right? So this implies I can calculate the V max is equal to square root of 50 is already there, 50 into 10 to the minus 3 into the resistance value, right? Load is 100. That is a V max. 2.23, okay. 2.23 volts, right? And how do you calculate a V min? What is the relationship between V max and V min? I think we have a relationship. Uh, there is a relationship. I think this one. Just verify. S itself is V max by V min, right? I know S. Yes, we have calculated. Correct. S is 2. Yes, yes, yes. Okay, so that implies correct. 1.115 volts. Perfect. Let's move further. The last part says that what are the Z values, correct? So Z at V min is equal to, I think Z naught by S. Just check this equation once. I think that's the value. Because V min should have minimum value of impedance, correct? So Z naught is given as a 50, correct? Divided by S is 2. 25. So similarly, the Z at V max is equal to Z naught into S. So 50 into 2, so that is equal to 100. Is it okay? This part? Okay, let's move on. Next question. The short circuit and open circuit impedances of a 10-kilometer transmission line are ZSC equals to 2930 at an angle 26 degrees and ZOC equal to 260 at an angle minus 32, there is a negative, okay, minus 32 degrees. Forms at 1 kilohertz. Calculate the, okay, characteristic impedance and phase velocity. Okay, right. Now, I think Z naught is a straightforward answer here. Do you remember any equation that relates the given data to Z naught? Short circuit impedance given, open circuit impedance given, frequency given, and the length, yeah, length of the line is given. We should try to relate any of these four given parameters into the Z naught. Yeah, sure. Yes. Just no. Both are, see, the meaning of the given data is that there is no fixed value of impedance. Okay. So on the other side, when you short circuit, right, you can see that there is a resistance of 2930. Okay. At the same time, if the load is open circuit impedance, you can see that there is a impedance of 260. Right. 260 angle minus 32. So that's what is a given data, right? Value of impedance at the load connect value is not given. So how do you relate the short circuit impedance and open circuit impedance into the, there is one equation. Yeah, I think after that, after that part, we modified that to get this equation. Just check now. Z naught is equal to root of ZSC short circuit into ZOC. Right? We have this equation. We didn't do that. Oh, I'll just verify. Let me check. See here. I think we wrote it in a other format. ZL into ZS, right? No. Z not equal to ZL into Z, root of ZL into ZS. Somewhere have you? It's there, right? The same one, same one. Okay. Right. So apply that here. So that is equal to square root of, we'll simply apply. Okay. 2930 at an angle 26. Correct. I'll write just a second. 872.11. Okay. 811. Okay. 0.81 at an angle minus 32. Yes, yes, yes. So minus 6 by 2. So that should be minus 3 degrees. Okay, so much ohms. That's okay. Now we also have another equation to calculate the uh, phase velocity. Okay, first let's write that. What's the equation to calculate the phase velocity? Vp is equal to, it's omega by beta. Okay, so omega can be calculated, frequency is given 2 pi f, but beta I have to go for a first I need to find gamma, right? No, here the beta is not the right, this has to come from, right, it's a propagation constant, right? Right. So I have to calculate from there, right? Omega can be directly calculated, but beta, I have to do a calculation. So that comes from the gamma, isn't it? Okay, so let us calculate the gamma first. So gamma into L, I think this one, the tan hyperbolic. Tan h of gamma L is equal to root of ZSC by ZOC. Okay, so we'll substitute under root ZSC. So 260 angle minus 32 divided by 9 angle 26. Okay, this is 0. Okay. Okay. Okay, this is minus 29. Right, this is tan h, but you see I need the gamma L first. So that is equal to tan hyperbolic inverse. Tan h inverse. Tan h inverse of this number, whatever is given. Okay, so 0.297 at an angle minus 29 degree. Do you have this in the calculator? Can you check? Tan h inverse. Tan h. Okay. No imaginary part. Then we need to go for a longer method. Okay, let me just check quickly on my calculator. Okay, is it possible? It normally it will take, I guess, but if it is not there, then it's going to be a longer solution. Okay, if it comes, then good. Math error. Oh. It's in degrees, 29 degrees. And yes, not coming. 0.2. Only if you can enter 297, it comes, is it? Hmm. Okay. No, angle, in that case, angle cannot be entered, right? Angle 29, if you write. No, can we enter it in the Huh, okay, okay. That's also error. Okay, then all right. I'll tell you a method, okay, which can be applied. We'll solve the problem together, right? Right. But as a I'll tell you the method we have to apply. Okay. So that is okay. I'll just write on this side. So here we'll solve the actual problem, right? But right, I want you to try. Then we'll solve together. Okay. Meanwhile, I'll also do. So the tan. Okay. This is what we have. We have the tan h of gamma L equal to, on the right hand side we have some number. Okay, so that is I think 0.297 at an angle minus 29. Okay, this is fine. Anyway, we'll convert that into the alpha plus j beta format. But first let me go for what is the equation for tan h of gamma L. So it's, what is the tan ratio? It's a sine by cos, sin h by cos h. So sin h defines e to the power gamma L, okay, minus e to the power minus gamma L all divided by e to the gamma L plus e to the power gamma L minus gamma L. Okay, this is equal to whatever we have on the right side. So what I have to do, I have to multiply and divide by the, only for this left hand side I need to multiply and divide by, see I need to have what you call rationalize, perform the rationalization by multiplying and dividing by the e to the power gamma L minus e to the power minus gamma L, so that the denominator gets rationalized. A plus b into a minus b is a square minus b square, right? That will simplify this into a certain format. I'm expecting something like this. E to the power, I think we get this. E to the power minus 2 times gamma L equal to, right hand side still remains same. Okay, you may have some constant coming up here in the denominator that will be multiplied. Okay, onto this side, whatever we have here. Now you see, it is e to the power something, right? When I have e to the power, I need this power to come down, means you take anti-log, correct? Because e to the power, if you want to cancel that, right, you simply have to take the take natural log on both sides. Okay, ln of this number e to the power minus 2 gamma L should be equal to ln of this number, whatever you have on the right side. Okay, so here ln and e cancels. In your next step you are bringing the gamma down, so that is minus 2 gamma L equal to some number, because ln of something is a number, right? You get a number, and in the next step I want to get a gamma. So gamma is equal to whatever you have here divided by minus 2 times L. Length is given, I think, how much? 10 kilometers, right? When you substitute, you get a gamma, which is again something plus j something, out of which this is my alpha, this is the beta. Take a beta from here and substitute in the equation, you get back the vp value, phase velocity. Okay, it's going to take some time. This calculation is not easy. That's why first let me think about, is it possible to do it in calculator? Otherwise this is going to take a lot of time. All right, we'll see, right? I will also spend time on this in the calculator mode. If it is not possible, I'll teach, we will solve together how to go ahead with this part. Okay, meanwhile, anyway, this is the method you can try, right? But anyway, I'm not expecting you to completely solve this, right? I will teach you how to do that.